Here to talk about a common application we come across, proving airflow across a blower. You see this application all the time when we're out in the field. Simple to do. We use an airflow switch. They come in a couple different shapes and sizes. They all work basically the same. They have two connections. There's a high pressure connection and a low pressure connection. You tube that right over. We're going to be working with a suction side of the fan where the low pressure exists, and the high pressure or exhaust side of the fan where the pressure is higher. Three ways we can hook up an airflow switch. If you have plenty of pressure, we just take one sensing line from a pressure port, put it in line right ahead of the fan, and we can prove through this switch making that fan is making pressure. If we have suction available to us, we can take that sensing line, run from the low pressure side, go before the fan, and prove it that way. If we have a small airflow and a small differential pressure, then we hook up two sensing lines differentially, one before the fan, one after the fan, and take a differential pressure measurement with this airflow switch. While you're at that, do yourself a favor, use 3/8 tubing rather than 1/4 inch. 1/4 inch is usually pretty convenient. It's usually the first thing people grab. Do yourself the favor, use the bigger tubing. You won't get as much restriction. You'll be in and out in no time. Here's a little graphic on how it's set up. We have a fan. Here's our airflow switch. Low pressure port hooked up before the blower. High pressure port goes up to the high pressure side of the blower. We're now taking a differential measurement across that fan and know for certain whether it's running or not. To check differential pressure, you need the right tool for the job. You can use anything that will measure differential pressure, a magnehelic gauge, a slack tube manometer. The tool we like to use is this Testo 510. Very convenient, easy, it's got lots of ranges. Set it to the right range, probably inches of water column. Hook up right here to your sensing tubes that are coming from the up and downstream sides of the fan, and you're ready to measure. It's just that simple. For a couple $100, you got a great tool. Available here at StromQuest. Here we have two very common airflow switches, the JD2 and the AFS 145. Both pipe the same. The low pressure or suction port is on top. The pressure or higher pressure port is on the bottom. That's important. It will not function if they're turned backwards. If we're hooking them up differentially, we go from the low side before the fan, the high side to after the fan, and we're good to go. You hook it up that way, set your pressure, you're in and out in no time. Adjusting the spring is a simple matter. The spring is in here. Simply remove the nut and put a screwdriver in, and it's a simple righty-tighty, lefty-loose. As you advance the thread, it tightens up on the spring, raises the set point. You just want the airflow switch set so that you're making with the amount of pressure that you have on the blower. From a practical standpoint, where you'll be seeing this problem is a burner or boiler application that begins to purge but never leaves the purge cycle. Indicates to you that an airflow switch may not be made up. Maybe you just need to adjust the setting. Maybe we need to look at, are the sensing lines plugged? Are they where they belong? We've already covered where they should be. Taking a look at those tubes, making sure you got 3/8 size tubing is a good idea. Take a look to see that the fan is turning the correct direction so that you're generating pressure the way you think you're generating pressure. That should solve your problem with an airflow switch with a burner or boiler that won't operate because of airflow questions. This safety message is brought to you by your friends at StromQuest & Company.